Now we are going to draw or to sketch the graph of trigonometric functions. Firstly is the graph of sine. Consider the function of y equals sine x for 0 degree less than or equal x less than or equals 360 degree. Using the table values of x and y, we will plot the graph. So the table will be like this. From 0 degree until 360 degree, we will choose the spatial angles so it is easier to see. And then substitute the corresponding values of x into y. So for example, x equals 0 degree, then the value of y equals 0, and we will use this sign as corresponding x, y. This is the graph of y equals sine x. The maximum value of sine x is 1 and the minimum value is negative 1. How about graph of cosine? Consider the function of y equals cosine x for 0 degree less than or equals x less than or equals 360 degree. Just like the sine function, we set the values for spatial angles. Plot all the points, we will have this following graph. We see that the maximum value is 1 and the negative 1 as the minimum value. Let's see the graph of tangent. Consider the function of y equals tangent x for 0 degree less than x less than equals 360 degree. Set the values of x in the table using the spatial angles and find the value of y. As usual, we plot the points using this sign to the corresponding point x, y. So this is the graph of tangent x for the interval 0 degree until 360 degree. There is no maximum and there is no minimum value of y equals tangent x. We have to know some trigonometric terms related to the graphs, that is amplitude and the period. So the amplitude is a half of the difference between the maximum and minimum values of the graph. The formula is half of the maximum minus minimum. A function is called a periodic function if the values of the function are repeated at regular intervals. The period of the function is the length of the interval between the repetitions. Now if we take a look deeper for the graph of sine, we have the following properties for y equals sine x. The maximum value equals 1, the minimum value of a negative 1, and the amplitude equals 1, because amplitude equals half times maximum minus minimum equals half times 1 minus minus 1 equals 1 over 2 times 2 equals 1. The period is 360 degree because sine 360 degree plus x equals sine x. The curve repeats itself every 360 degree. The graph of y equals sine x is symmetrical about the origin. We have the following properties of y equals cosine x. The maximum value equals 1, the minimum value of negative 1, and the amplitude equals 1 using the formula of amplitude. The period is 360 degree because cosine 360 degree plus x equals cosine x. The curve repeats itself every 360 degree. The graph of y equals cosine x is symmetrical about the y-axis. And here are the properties of the graph of y equals tangent x. No maximum and minimum value, so there is no any amplitude, and then the period is 180 degree, tangent 180 degree plus x equals tangent x. The curve repeats itself every 180 degree, and this graph is symmetrical about the origin. The last one, the graph has asymptotes of the lines x equals 90 degree, 270 degree, etc. because they are not defined here. These following are the properties of some common trigonometric functions. In this table, we will see the function of the trigonometric functions with the maximum value, minimum value, amplitude, period, and y-intercepts. Example 1. On the same diagram, sketch the graphs of y equals sine x and y equals 4 sine x for negative 270 degree less than equals x less than equals 270 degree. B. Sketch the graph of y equals absolute value of 4 sine x for negative 270 degree less than equal x less than equal 270 degree. And here is the solution. For part A, this is the table of the values from negative 270 degree to 270 degree. To make it easier, use the spatial angles. And we have the value of respective functions. The first one is for y equals sine x and the second one equals 4 sine x. For part B, we use the table and set the table of value of x and y for the same interval. The absolute value doesn't have any negative value. Here is the graph for y equals sine x with the table, and here is the graph of y equals 4 sine x with the table. We can easily find the difference between y equals 4 sine x and y equals sine x. For part B, the graph of y equals 4 sine x is this one. And from the graph, there is no any negative value. The maximum value of y equals 4 sine x is 4. Example 2, part A. State the period P in degrees of the graph of y equals 5 tangent 4x. Part B, draw the graph of y equals 5 tangent 4x for 0 degree less than equal x less than equals p. And here is the solution. Part A, y equals 5 tangent 4x. For the previous property, we have that for function y equals a times tangent bx, the maximum value does not exist, the minimum value does not exist, the amplitude is undefined, the period is 180 degree over b, and the y-intercept is 0. So, based on the question, we just need to find the period of the function. So for y equals 5 tangent 4x, a equals 5 and b equals 4. Now we will use this to find the period, which is 180 degree over b. So the period equals 180 degree over 4 because b equals 4. So p equals 45 degree. Using this value, we obtain the graph of b. So we will draw y equals 5 tangent 4x for 0 degree less than equals x less than equals 45 degree. So this is the table of the values, and we will sketch one by one. And here is the graph of y equals 5 tangent 4x. Stay at home, tetap semangat!